Hi everybody and welcome to day 3 in your series of lessons on missing angles. So in lesson 1 you looked at finding missing angles in right angles. Lesson 2 you looked at finding missing angles on a straight line, and today we are looking at finding missing angles in triangles and quadrilaterals. Before we get started, I would like to remind you of the types of triangle. There are 3 types of triangle, but 2 of those can be then split again into different ones. So the first type of triangle we've got is the regular triangle, and if you remember from our lessons on regular shapes, that means that all the sides are the same length and all the angles are the same. And that regular triangle is called an equilateral triangle. Equal. And it's easy to remember because it's got equal in it. It's not quite spelt equal, but it's got the word equal in it because the sides and the angles are equal. So that's our equilateral. And with the equilateral, you can only have the triangle that looks like this. It can be orientated differently, so you could have the straight line along the top, you could have the straight line going sort of slightly more diagonal like that, but it will always look like this, bigger or smaller possibly, but that. And we'll talk about the size of the angles in a minute. The next type of triangle are when we have 2 equal sides and then a third side that is a different length. And because we have 2 equal sides, that means we will also have 2 equal angles. That's called an isosceles triangle. Isosceles triangle. And we can get a right-angled isosceles triangle. So as you can see in the example down here, we've got a right angle at the bottom, and then these 2 sides, here and here, in this case it's the vertical and the horizontal, are equal. But this side, the one opposite the right angle, is longer. And the side opposite the right angle is actually called the hypotenuse. And you don't need to know that yet, but you will do in the future. So the hypotenuse is a longer side, and then the other 2 are shorter. And again, it can be orientated in different ways. You could have the right angle at the top like that, or you could have the right angle at a point like that. So as long as you've got 2 angles, 2 sides the same length and right angle, it's a right-angled isosceles. Or you can just have a normal isosceles without a right angle. And the final type of triangle is a scalene triangle, and that's where, you can probably guess, all 3 sides are different lengths and all 3 angles are different. And again, you can get a right-angled version of that. Some people think that this side and this side look the same length, but actually the hypotenuse, which is the one opposite the right angle, if you were to close that down, it would reach about here. It's actually longer. So all 3 sides are different lengths on both of these, and this is the right-angled version. So that we have 3 main types of triangle, but on 2 of those you can get the right-angled version too. So equilateral, all sides and angles equal. Isosceles, 2 sides and angles equal. Scalene, no sides and angles equal. So let's now have a look at the angles, because we're going to be working out missing angles. So the angles in a triangle have a really interesting property, and that is that all 3 of them will add up to exactly the same amount as a straight line. They all add up to 180 degrees. So if I were to tell you that, you should be able to, from that, work out on every single equilateral triangle how big the angles are. Every single equilateral triangle will have the same size angles. We already know all 3 are the same, and we know that they total 180 degrees. So what we need to think about is how many 60s I've just told you the answer, sorry. How many 3s there are in 180? We've got to split 180 into 3. And I've just told you the answer. But what you would need to do is think about 18 times 3, which is 6, and make it 10 times bigger. It's 60. Sorry, I told you the answer in advance. So on an equilateral triangle, every single angle is 60 degrees. Whatever the equilateral triangle, doesn't matter how big it is. Each side could be a mile long, could be 100 miles long, and they will all still equal 60 degrees each. Right, now on isosceles, as you know, 2 of those angles are the same. On the right-angled version, well, you already know one of them. You know the right-angled one, which is, of course, 90 degrees. So what we now need to do is think, well, they add up to 180. One of them is 90, so I'm going to take that away. And actually 90 is half of 180, so that will leave me with 90. So these two together add up to 90. So if I then halve 90, that gives me these angles. Half of 90 is 45. So each of those angles is 45 degrees. With a non-right-angled isosceles triangle like this one, we can't say for definite. It depends how long the baseline is, really, in comparison to the sides. So you could have a much flatter isosceles triangle like this one. So we can't, unlike the other two we've done so far, we can't say for definite how long that is. What we do know is that these two will be equal. Whatever they are, they will be equal. And all 3 will add up to 180. And the same with the scalene triangle. Even if we know this one is 90, we don't necessarily know these two because, again, it depends on the size of the sides and the angle that they are meeting at. And we don't know with these 3 either. What we do know is that they will add up to 180. So let's just have a look at this problem here. And this is the sort of thing you're going to be doing in your work today. This is a triangle. At the moment, I'm not sure whether it's an isosceles or a scalene. It looks like it should be an isosceles because it looks like these 2 sides are of equal length, but I know they're not. Can you work out how I know that this can't be an isosceles triangle? How I know these 2 can't be equal lengths? It's because of the angles. These angles are different. They're only slightly different, but they're different enough that actually I think it's this side that's a little bit longer than this side. So I think this is actually a scalene triangle, even though it looks quite like an isosceles, because these are different. So we've got to work out the value of angle x. And do you remember we said last time that x is like algebra? Oh, it is algebra, sorry. It's a missing number. And x just means the missing number. So we need to find the missing number, the missing angle. So what I could do here, I could either do 180, take away 70, take away 60. This is exactly the same as finding the straight line. Or I could combine my 60 and 70 and take that away. And that's what I'm going to do because I can do that in my head. I know that 70 add half of the 60 is 100 because that's that takes 30 from the 60, plus the other 30 is 130. And then I can do 180 take 130 in my head. I know that 80 take 30 is 50. So I know that this angle is 50 degrees, which means it's definitely a scalene triangle. All 3 angles are different. And then I can add those up just to check. 70 plus 50 is 120, add 60 is 180. So that's my missing angle. That's the sort of work you're going to be doing today. Just to move you on a little bit more, this first one is just like the one we've done, this 70 and 45 one. So again, I'm going to combine those, and I know that 70 add 30 is 100, which leaves me with another 15 out of this, so that's 115. So then I need to think about 180, take 115, 80 take 15 is 65, and 100 cancels it out. So this one will be 65 degrees. Now, this one, I've got two missing angles. However, because they're both labelled X, that means it's the same number. If they were different, one would be X and one would be Y, and that would show that they're different numbers. But these must be the same, which means they're equal. It's an isosceles triangle. So on this one, I would start by taking away the 110, which leaves me with 70. Take away 110, which leaves me with 70. But the 70 is for both of these combined. And because they're both equal, what I need to do is divide my 70 by 2 to find out how much each is worth. Half of 70 is 35. So each of these angles is 35 degrees. And then again, I can check that. 100 add 30 is 140. Add another 30 is 170. Add the two 5s is 180. Now, what do you notice about these bottom two? We're trying to find what's called exterior angles as well, which are the angles outside. But if you look, what have we got along here? Oh, my pen stopped working. That's interesting. Sorry about that. Right, there we go. What have we got along here? We've got a straight line. So what do we know about X and Y? We know that those two also add up to 180. So the three angles inside the triangle add up to 180, but X and Y on their own add up to 180. So first of all, I need to find Y. And I can find Y because I know two of the angles. So I'm going to combine my 62 and 51. 50 add 60 is 110. Add the 2 and the 1 is 103. So I need to do 180, take away 103. Well, the hundreds cancel each other out. So 80 take away 3 is 77. So that angle is 77 degrees. Now I know that X is 180 minus 77, because this is also 180 degrees here. So if I take away 180, take away 77, well, the 100 I'm going to keep this time. So I'm going to do 80 take away 77, which leaves me with 3. 103. Have you noticed anything? Did you notice that this angle here was equal to these two angles combined? Why would that be? It's because this, add these two, equal 180. So this, add this equals 180. And these two must be the same value as this, because this is part of the 180. So in this one it's split into 3, whereas this one it's only split into 2. So this must be the same value as those two combined. That's really interesting. I wonder if the same works over here. Now on this one, we've got two different angles to find, X and Y. Because they're different letters, they're also different numbers. I can start here. I can't find Y yet, but I can find X, because these two angles here will add up to 180. They're on a straight line along here. 120, and I know we must have a missing 60, because 60 and 120 make 180. So now I can work out Y, because these three angles will add up to 180. So 70 add 60 is 130. 180 take away 130 is 50. And there are my three angles. Okay, we're going to quickly move on to quadrilaterals now. Just to remind you of some of the quadrilaterals we've got, just pause this page for me and have a read through of the properties of quadrilaterals. The only ones I'm going to add are, before you do that, are to the trapezium here. I would like to add, because now you know about an isosceles triangle, and you know I can't draw straight lines on this. Now you know about an isosceles triangle. An isosceles trapezium would be an isosceles triangle with the roof cut off. So they're supposed to be straight lines. I'm not very good at drawing them. I should have got a picture on the internet like the others. So we have, imagine an isosceles triangle like that, but the roof's been cut off. So if I cut straight along there, and that's my isosceles trapezium. So it's slightly different to just a normal trapezium. So just pause this page now and have a read through and see if you can remember. And just remember for me, there's no such shape as a diamond. That is actually a rhombus. So please remember that. So just have a look at this page and pause it for me. Okay. I hope you had a read through all of those. Now, what's interesting in a quadrilateral is the angles in a quadrilateral don't add up to 180. They are double that. They add up to a full turn. They add up to 360, the same number of degrees as a full turn. If you think about starting from a position, turning all the way around back to where you started, that's 360 degrees. And that's what a quadrilateral adds up to, because you've got four angles, and you've got two sets of straight lines in that, if you like. Also, what you don't really need to know at the moment, but is useful to know, is the exterior angles. If you were to draw straight lines coming out from the sides, the exterior angles also add up to 360 degrees. But for the moment, we're just looking at the internal, because also you know that these two will add up to 180 because they're on a straight line. But let's just look at these. We know that angle A, add angle B, add angle C, add angle D equals 360. Now, I can't tell you how big any of these angles are because none of them are labelled. But we know that they will add up to a 360. So let's just have a look at some missing angle problems here. This first one, remember, they're going to add up to 360. So I need to find the value of angle X. So I need to think, I'm going to do my normal method of combining all three, in this case, angles, and then subtracting them rather than subtracting them individually. I just find that easier. So 105 add 80 is 185. I'm then going to add the other 5 from here, which is 190, and then the 70. So 190 add 70 is 260. So 360 take 260. Well, that's nice and easy. 360 take 260 leaves me with 100. So this angle here, angle X, is 100 degrees. And again, I can double check by adding them all together. 205, 285, add the 5 is 290, add 70 is 360. Okay, the second puzzle, only one angle is labelled. I need to find the value of W. However, look at what we have here. Two little squares in the corner, which means they're right angles. So both of those add up to 90. Are both 90, sorry. So they add up to 180. So I can now add all three angles. I know these two are 180. Now I need to combine that with 146. So that would be 280 plus 40 is 320 plus 6 is 326. So I need to do 360 take 326. Okay, so 360, the 300s will cancel each other out. 60 take 20 is 40. Take away 6 is 34. So this angle here should equal 34 degrees. And again, we can add them all together to check. 180 for those two. Add the 100 is 280. Add 40 is 320. Add 30 is 350. Add 6 is 356. Add 4, 360. So your task today is to have a look at the sheet that is in the website, and it's got missing angles for both triangles and quadrilaterals. And there are a few trickier ones. There are some greater depth ones there as well towards the end. So have a go. Don't forget, if you see the square in the corner, it's a right angle. And don't forget, if you extend the side of a shape like this, you've got a straight line. So sometimes you might get a question where, for example, down here, that wasn't very straight again, was it? This angle here is labelled, and you've then got to find this one, the internal. We call this one the exterior angle, and this is the internal angle. So you may find that the exterior angle is labelled, but you've got to find the internal, and you know that these two must add up to 180 because they're on a straight line, even though the insides on a quadrilateral add up to 360. So main things to remember today: right angle, if you see the square, it's 90. Straight line is 180, and you may see that on the corner of a quadrilateral like this. So just remember those two there will be 180. Triangles equal 180. Don't forget equilateral triangles, always 60 each. And quadrilaterals, 360. So that is your cheat sheet for today. Don't forget those values. Pause on this page if you want to. And good luck with that sheet. And the rest of the lessons for this week you'll be doing in school. So that's your last home lesson for this week. The rest you'll be doing in school. See you all there. Bye-bye.